Okay, this video is going to teach you about triangles. The first 2 pages of the notes should be a review for you. However, if you've forgotten any of it, then you should write it in your notes. If you remember all this, don't worry about it. The first thing we're going to talk about is classifying triangles. When you classify a triangle, you can do it by its angles or by its sides. If you were classifying it by its angles, you could say it's acute, which means that all of the angles are acute, less than 90 degrees. Right means that it has exactly one right angle, or exactly 90 degrees for one of them. Remember, that's given away in the picture by the little box in the corner. Obtuse means that there's one obtuse angle larger than 90 degrees. Also, you need to remember that the sum of all the angles in a triangle is equal to 180 degrees. Now, if you're classifying the triangle by its sides, a scalene means that all the sides have different lengths. Isosceles, 2 sides have the same length. And equilateral, all sides have the same length. Next, we got to go over markings. When I'm talking about markings, there's a few things that I'm referring to. First of all, for an angle, we use this. That's the symbol that means angle. For measure, we use a lowercase italicized m. So if I had, or if you saw this in the book or in notes somewhere, that means the measure of angle B. The next thing that I want to talk about is when you are looking at these little hash marks here on the triangles. If you have this and this, those 2 arcs mean that those 2 angles have the exact same measurement. Also, if I look at these 2 little hash marks, these 2 little hash marks, that means that those 2 sides have the exact same measurement. So markings are important when you're looking at diagrams, either in a book or in notes or anywhere else. If you see those, you match up the markings. That means that those sides are the same, or the angle measures are the same if the arcs have the same number of arcs or same number of marks. Okay, the first thing that I want you to see is that a straight angle is 180 degrees. So, I'm going to start with my protractor, and I'm going to draw a ray. Here is a ray. Then I'm going to line this up, and I'm going to measure around 180 degrees, which is over here. Then I'm going to draw another ray. Lo and behold, a straight angle, well, that's not lined up very well, is it? That's funny. A straight angle is 180 degrees, and you can see that on this protractor too. Okay, if you start here and you count all the way around, it's 180. If you start on this outside scale all the way around, it's 180. 180 is a straight line. So, one of the things that we said is that the sum of all measures of a triangle, the angles of a triangle, is equal to 180 degrees. So, let's prove it. Here is an equilateral triangle. Here is an acute equilateral triangle, Here is a right triangle, and here is an obtuse triangle. These 3 angles should add up to 180 degrees for a straight line. These 3 should add up to 180 degrees. These 3 should add up to 180 degrees. And it doesn't matter what these triangles are. They're not any special triangles. You can see these were brought to you courtesy of C&E Paving. Thank you, C&E Paving. I just cut them out of a piece of paper. It doesn't matter. A triangle, all angles of a triangle always add up to 180. So let's prove it. Let's take this acute equilateral triangle first. Now I marked the angles on here just so once I cut my paper up, it'll be easier to line these things up. This is cut up into 3 pieces. If I take these pieces and I put the angles together along this line, like this, look at that. They form a 180 degree straight angle because the sum of the angles of a triangle always add up to 180. Now let's try this one, my right triangle. So it worked for an acute, should work for a right. This one's really small. I don't know what I was thinking making one this tiny. Okay, take this, we'll line it up right there. Now we'll take another angle, put it in here, and then we have one more angle to do, and it is a 90, and look at that. Voila! 180 degrees. Beautiful. I love it when things work. Now we'll take this obtuse, cut that off, cut that off. Let's line up these. There's my angle. There's my other angle. And the last one, will it work? Of course it works, because in math, the sum of the angles of a triangle always equals 180 degrees or a straight line. Thank you very much.
Oh no, there's nothing drawn here. That's all right, I'll draw it. Find the value of x, then classify the triangle by its angle measures. So first thing I'm going to do is I'm going to start with a triangle like this. Like that. And I'm going to say this is 2x degrees, this is 2x degrees, and this is 60 degrees. Now I know some of you are very sharp and you say, well look, I know the sum is 180. If the top is 60, that means the bottom two are 120, and they're the same. Divide by 2 is 60. Oh, look, they're all 60. But let's assume you don't see that. What you would do is you would say, all right, well, 2x plus 2x plus 60 is equal to 180, the sum of the angles. That's 4x plus 60 is equal to 180. Oops. 4x is equal to 120, and x is 30, which means that each one of these angles are 60. So it's an acute triangle. It would also be equilateral. And x is equal to 30. So the next one is not going to be as obvious. If you want to try this one, you can. Let's see, I'll draw like this. And then I'll come down here like this. And I'll go like this. There. And I'll say that this angle right here is x plus 25 degrees. This one is going to be x degrees. And this one right here is going to be 25 degrees. All right, you would do this the exact same way. We have x plus the x plus 25 is equal to 180. If 2x plus 50 is equal to 180, 2x is 130, x is 65. So that means that this is, first of all, answer the first part, x is 65 degrees, and it is a right triangle, because if I put 65 up here, I have 65 plus 25 is 90, and then this one over here is just 65. Okay? Cool.